I just got it from somebody who almost quite literally took it off one of his shelves and pressed it into my hands, like saying, "Well, I know you like electronics, vintage electronics. Well, here you go. Take this amplifier with you and have fun with it." The amplifier doesn't have two outputs for, I mean, a regular stereo amplifier. It actually has four speaker outputs. Alright? So, which would suggest that maybe it is built for a quadraphonic sound experience, or maybe it's simply dual stereo. Well, obviously I can see this, which is the transformer. Okay. I also see this block of foam, which I suppose is meant to support a little bit the weight of the housing. Yeah. And funnily enough, they glued this block to the filter capacitors of, I would guess, the power supply here. Yeah. There are two huge 10,000 microfarad 35 volts capacitors right here. Okay. What else can I see? Well, we can see a board with tone control and all that. So obviously you can see here these two little boards here at the front, which are the LED output displays, yeah, output power displays. So these two little boards here, and then of course you have right here the tone control board. All right, and it's a little bit sloppy. It's built, but in a rather, I would say, sloppy way. So certainly not the way I'm used to from Sony. I mean, often Sony equipment is rather neatly built inside. This has a more, I don't know, let's say sloppy feel to it. Right, what else do we see when we reverse the whole amplifier? We see this here, and this is the, I would say this is the amplifier chip, yeah, and I'm not too fond of this. Basically, I mean, I would say the sound quality of these stereo chips is okay. You know, but really the disadvantage of these things is when they fail. So when one of the channels fail, then basically you automatically condemn the other channel as well. Now, I do see a sticker on the chip which reads OK, and I would think this is the 6th of August 91, I suppose, yeah, the 6th of August 91. So I don't know, either somebody checked the chip for normal functioning and said it's okay, or the chip got replaced and checked out fine, which would be what this sticker would mean. Okay, like I said, I don't know when this amplifier, this model, was built. My guess would have been in the 80s, but it it could just as well have been somewhere around the 90s as well. What else can I say? Well, none of the capacitors seem damaged, although, actually no, I do see one capacitor which looks a little bit damaged. Yeah, and either way, I am going to replace all the electrolytic capacitors in this amplifier. But there is indeed one capacitor which is slightly damaged. I don't know if I can zoom in on it, but let me try. Right here, this capacitor here looks damaged, and I think you can see it right here. There's like, I don't know, a dent or something to it, or maybe even it looks like maybe it looks a bit swollen on its top. So you can tell this is the kind of electrolytic which, when it goes bad, will vent on the top. Alright, so the top will, as it were, bloom open or fold open. Yeah, the petals folding outward and letting the capacitor vent. But right here, there's like a little dimple or a swelling of the capacitor. I can't tell, so it looks suspicious. The power supply filter capacitors look okay. Let's see, can I zoom out a little? So these look okay. What is annoying though, and I really hate that when they do that, is that they are glued together. And I mean, not only the capacitors are glued together, but the foam block, which is this foam block, is glued to the top of these capacitors. And it's an absolute horrible thing to do. Really a cheap, horrible way of working. Also, what you notice down here, right here, this area here, is very, very sloppy. Yeah, so I don't like it. I don't like the looks of it. It looks, you know, cobbled together, not very clean. For, I suspect, a rather expensive, type of amplifier. Other than that, well, it looks okay. Yeah, dusty, bit dirty, yada yada yada. So yeah, no, nothing out of the ordinary, I would say. It's surprisingly empty inside. This side of the amplifier case is completely empty. So I suspect Sony built these cases to be used for other devices, you know, like a tuner or something like that, or a preamplifier, and what they would do is just bolt another front to a standard case. Alright, so I unscrewed a single Phillips screw. Okay, so now we can lift up the little board, which normally should have a fuse assembly. And do you see any fuse? Because I don't. There's absolutely no fuse in here. Actually, no. Are you joking? Is this the fuse? Yes, it is. Actually, these two things are. Can you imagine that? So they fused the amplifier with two little wires. One here and one there. They even left the insulation on this little wire. Imagine that. Wow. So yes, I'm very disappointed, Sony. Really, I'm really disappointed that you would cut corners that way. I mean, this is irresponsible. Yeah, so if this ever got a voltage spike through the AC plug, or God forbid some lightning coming through the AC outlet, or even a short circuit internally, well, yeah, with this as a fuse, or this, well, yeah, that's not going to work. At least it's not going to work for me. So this is definitely something that I will modify. Now, also, it would seem Sony used glue to glue wires and components to the PCB. And if you take a close look here, you'll see that there is, I would say, a sort of corrosion going on right here. Yeah? Whoop. Right there. There seems to be some corrosion going on the wires. And precisely where that glue is sticking. So, I'm not entirely happy that glue being there. So I'm probably going to spend some time cleaning it off. I don't know yet how precisely I'm going to get the glue off, but I'm going to use a gentle method first, which is using petrol, basically. So, and when I say petrol, I literally mean petrol. Hang on. Yeah. So, like this. Alright. So, this is basically the same thing you throw into your car, yeah, to drive on. Only it has a different color and a slightly different composition. It's purer, actually, I think, than the petrol in your car's tank, okay? But it's basically the same thing, and this usually works quite well with glue, you know. So it does make glue release a lot faster. So instead of using heat, I will first try this, and then we'll see whether I can clean off the glue with petrol or with some other means. Alright, that foam pad you see down there, yeah, is stuck to the top of these large electrolytic capacitors with, I would say, double-sided tape with some glue on it. So I have a little brush here impregnated with petrol. So what I'm going to do now is saturate the top of the foam block with the glue with some petrol. Then I'm going to wait for a minute or so and then see whether the foam block will simply release of its own accord, or with just a little bit of force applied. Alright, we're about a minute later, so let's see whether the petrol is doing its work. Oh yeah, oh yeah, very nicely. So yeah, and I'm not joking. I literally waited a full minute, yeah, soaking the top of this foam block with petrol. That's all I literally did. And there you go. It's loose. Just using a little bit of petrol. So I replaced the original capacitors that were built into the amplifier, the Sony TA-242. So there were two of them, yeah, and these capacitors, these two original ones, are a bit strange in the sense that they have 3 pins actually, and not 2. But the third pin, the one in the center here, is only meant to keep the capacitor housing firmly fixed to the PCB. Now, for some reason at Sony's factory, they had judged that it would be better to reinforce the attaching of the capacitors with some extra glue. And you see the remnants of the glue right here, that this yellowish stuff. It turns out that I didn't have too much trouble releasing this glue from the PCB by soaking it liberally with some cleaning petrol. In fact, like this. All right. So this is just petrol, really, regular petrol. And by gently lifting the glue with a small screwdriver like this, by scraping, but really gently scraping and lifting it off the PCB, I managed to release the original capacitors you see here. Now I replaced these two by two of these. So these are, in fact, 10,000 microfarad 35 volts, 85 degrees Celsius, pretty much like these. Okay, so this one is, okay, like this one, alright. These are Nichicon capacitors. This is more, you could say, a no-name brand, alright. You might wonder, yeah, why use a no-name brand? Well, you know, I have to, I'm making these videos out of my own pocket. So I, unfortunately, I'm not a rich YouTuber or influencer who can, in fact, finance their stuff from the revenues the videos make. Not yet anyway. So you might wonder, okay, did you really need to replace these capacitors? And I'll show you, in fact, why I did need to replace them. So let's connect this one up like this. Alright, like that. So now we push the test button. There you go. So the tester says it's a 5,000 microfarad capacitor, 5,000 microfarad, while it's rated for 10,000 microfarad. All right. It's also fairly lossy as a capacitor, so leaky, you could say. Leaky in an electrical way, obviously. Yeah. Anyway, yeah, you can tell the capacitance of the capacitor is not that good. It's half of what it's rated for. Now let's have a look at the new capacitor. Yeah. Like that. Like this. Let's test it. So there you go. 10.59 millifarad, which is effectively the same as 10,500 microfarad. It's far less lossy, and the internal ESR is really low as well. All right, which is really good. All right, so yes, these new capacitors will do just fine in the amplifier. So, and in fact, the original capacitors were mounted right here in this area. If you're going to replace capacitors on the amplifier's PCB, always take note of the symbol, alright? So this here is the placement, or the location I should say, of a 100 microfarad electrolytic capacitor. Notice the little cup symbol, yeah, with a little stem inside of it. So the cup side of the symbol indicates the negative side of the capacitor. The other part of the symbol indicates the anode or the positive side of the capacitor. And most of the time, although not always, the negative or cathode side of a capacitor, an electrolytic capacitor, is marked with minuses like here. Alright? Also take note that a lot of times, again not always, the anode or the positive lead of an electrolytic capacitor is always the longest one. I'm sure you noticed that these two leads have different lengths, alright? So the longest one is, in 99.99% of cases, is the anode. The other lead, the shorter one, is the negative. Okay? But never assume that that is the case automatically. Always double check. Because if you connect up an electrolytic incorrectly to the PCB, you might cause a heck of a lot of trouble. And in worst case, you might even destroy the appliance into which you built the capacitor. Alright, so I replaced all the electrolytics on the preamp board of the amplifier. In fact, on the schematic, it is described as an equalizer board. Yeah? and there's one, there is one, if I'm not mistaken, dual op-amp chip on the board, yeah, which functions pretty much as a preamplifier and a equalizer or tone correcting device. All right. Some of you who are more or better acquainted with record players will recognize that one of the functions of this little circuit is called a RIAA corrector, tone corrector. Yeah. So in effect, the sound output of record plays is rather thinny sounding, and you need to correct the sound coming from a record player to make it sound more fuller, yeah, more, I would say, natural sounding, and that's what a RIAA or an RIAA corrector does. Also, it probably corrects the levels, the input and output levels for the tape recorder output or input, for that matter. I didn't figure out yet exactly how the circuit is wired, but in the main, this is exactly what this board does. It is an equalizer board, just like the schematic says. So a preamplifier equalizer. On the back of the amplifier, there are two rows of speaker contacts. Alright. So, and one is contact row A, the other is contact row B. Alright. So speaker B output is here, speaker A output is here, and this is speaker output B. Now you'll notice the contacts on the left, which strangely enough are the contacts for the right speaker of the speaker B pair. Yeah. Look damaged, and if you look more closely, you'll notice that the damage looks like, well, heat damage, really. It's as if the contacts overheated. So, in effect, you could say the wires towards the speaker, or the contacts for the wires, overheated and melted the plastic. In fact, if you look inside, you see it melted pretty much through that red contact over there, and it did the same thing for the black contact. Okay, pretty much. So yeah, my guess is one of the speakers that was connected to the amplifier in the past shorted out, and that created an enormous draw of power. Well, I should say current on the amplifier. Now, I wanted to say as well that the amplifier is rated for 22 watts music power per channel. So, in effect, 20 watts, you could say, per channel. So, right and 20 watts for left. Alright? So, what I'm going to do now that I cleaned the speaker contacts thoroughly with a rag and some WD-40. I'm going to mount them back, and then I think we could have a shot at testing out the amplifier. Alright, I removed every single bit of glue on the print boards, or at least as far as I dare, without destroying anything. And I replaced all the capacitors, well, the electrolytic capacitors, on the main PCB, as you probably can tell. I'll give you a before-after picture later on, so that you can judge for yourself the work that has been done. I also cleaned the inside of the amplifier somewhat, removing some more dust and grime, and yeah, and it looks nice now. So everything is mounted back, except the cabinet itself, of course. So I think I've come to the point where we can fire it up, and I won't lie, I'm a little bit anxious. I want to see it work just as much as you would. So I hooked up the let's see. I hooked up my speakers to the speaker output A. Okay, so speaker pair A. Alright, so I hooked my speakers up to those. I mean, that seems like a logical place to start, I would say. And I also hooked it up to the AC outlet, and I also hooked up some audio cables to the what is this? Oh, the tuner input. All right, okay. So yeah, I hooked it up, and I'll try to play a few MP3s through the amplifier with the help of an old smartphone of mine. So yeah. Well, okay, just let me switch on everything, or get everything ready, and then we'll we'll switch on the amplifier together. Alright, so I hooked up an old smartphone with some copyright-free music on it, a few MP3s, and okay, so I set the volume knob to minimum, and all the other knobs to either center or lowest position. Alright, so okay, and we're running on 221 volts. Keep an eye on the lower numbers. They will show us the current draw of the amplifier. Alright, so well, like they say in English, here goes nothing. Okay, I didn't hear anything. Didn't hear the speakers pop or anything, so I'm listening through my lower speakers up there, so that and that one. Alright, so my lower speakers are the output. Okay, let's see. Let's play a song, shall we? There we go. Alright, so let's put some volume. Oh, this is no good. Okay. And the output is cool. I'm not feeling any heat here. So why am I not hearing anything? The lights are on. Wait, maybe the volume. No, the volume is good. Maybe a bad contact or so. Why am I not hearing anything? Oh, wait, maybe here? Okay. No. Not anything, not even a pop. Okay, let's switch it off. No. Not even a pop. This is basically cold. I mean, it's room temperature. Yeah. What? Yeah, the song is playing. Okay, so maybe this. Ah, that was it. Okay. Okay. Okay, the next song is playing. Okay. Now this looks promising. What am I looking at here? Oh, the balance, okay. Okay, this is not good. I'm not hearing sound from one of the speakers. Alright, it turned out that I had torn loose one of my speaker connections. So, well, let's hope this is it then. Okay, now let's see. Let's start the music. Okay. Oh yes. Okay. I can hear a difference in the bass sounds, but not in the treble. But then again, my ears are not so good. Well, let's see. Loudness. Oh yeah. Oh yeah. There's definitely a difference. Let's see with another song. Yeah, let's try this. This is a rap ripoff. Uh, oh, okay. Yeah, my phone has a sort of an ear protection. Uh, yeah, there is a difference. It's subtle, but there is one. Yeah, there is a difference. Right, center, left. Oh yeah, the loudness button definitely has effect. Let's check something else. Let's check the temperature of the output. (29°C). Okay. 84 Fahrenheit. On the output, transformer, (28°C), 82 Fahrenheit. Okay, so that looks like normal temperatures. Let's try the bridge rectifier. (74 Fahrenheit), 23.6 Celsius. Let's try the main filter capacitors. (24.6 C), 76 Fahrenheit. Alright. Well, I would say that looks pretty normal. So, yeah. So far, I'm happy with the result. Alright, before we close up the case on the Sony TA-242 amplifier, Let me give an overlook of it, um, and let me add a few comments of my own. So, what you see down there is basically the main amplifier board with the filters, you know, the treble and bass filters and the balance knob and the volume knob, etc. The power supply part, you know, and then up here, right here, these little boards are the VU meter boards, the LED boards, okay, and the selector switch board right here, all right. And then at the back, behind the power supply, there is the amplifier module or chip, if you prefer, which is an STK-460. Yeah, I took off the little label that was glued over the type number of the chip, and unfortunately that ruined the original markings of the chip. But since it's going to be serviced or maybe even repaired in the future by somebody else, I did my best to, as cleanly as possible, write down with white ink the type number of the chip. Okay, so it's an STK-460. And then at the back you see the input board, which contains a little preamp built around a dual op amp, yeah, with the record player, tuner, tape input, and tape outputs. All right. Now, a few final comments on this amplifier. It is okay. My hearing is not the best in the world, so I would not claim of being an expert on high fidelity. But as far as I can tell, this little amplifier does rather well. It's serviceable. It gives out 2 times 20 watts. Okay. And the looks are clean and sober and simple. And I would add, these looks are typical for the 80s. Remember, this amplifier, well, I would say this type of amplifier, was produced in the early 80s. According to my research, it would have been in 1980. All right. So basically, this server is 42 years old, and it needed a bit of TLC. Cleaning and replacing of the electrolytic capacitors, cleaning the contacts, lubricating them, etc. Which is normal, I would say, after 42 years. One thing, though, that I would say I don't like about this amplifier is the fact that it uses one of those combi integrated circuits. Okay, so the end stage, the power end stage, is contained for both channels, both output channels, is contained within one single chip. Now, sound-wise, I don't have any complaints about this. This works adequately, I would say even quite well. There is one big advantage, though. If one of the 2 channels blows, then you're basically condemned to replace this chip. Yeah, So to basically throw away one of the channels to have a functional amplifier again. And in fact, that is what happened with this amplifier. So you'll remember that on the sticker, this chip had to be replaced in the 90s. If I remember correctly, around 98. So 24 years ago. And my guess is what I just described exactly happened to this amplifier. Due to a short in a speaker, one of the output channels blew up in the original integrated circuit, and it had to be replaced, which is unfortunate, I would say. But in the user's or the owner's defense, I would say that this amplifier also makes use of those very unreliable clamp type speaker connectors. Okay, so where you clamp basically the wires of the speakers. And these, in my opinion, are not very reliable. I would have preferred to see the kinch type of connectors, basically like these here, which are far, far more reliable than these clamp type connectors, in my opinion. Unfortunately, that's what Sony did, and I'm guessing it was more of a cost-cutting decision than anything else. Also, there's one final thing that I would note. That is that the enclosure of the amplifier is basically half empty. Well, you see, the amplifier is basically covers half, the left half side of the amplifier, and the right side is empty. Now, if you look closely to the main board, you'll see that there is a switch missing over there, okay, and a connector over there, and yeah, there are a few parts missing, So my guess is that this amplifier, or this case rather, was also produced for higher model types than the TA-242. Yeah, who knows? Maybe, I don't know. I would need to look it up, but maybe the higher type would be a TA-343. Just saying, I don't know, but that could be the case, and in which case there would be, for example, an extra button right here, and an extra selector button right here, and also maybe an extra input or output on this board, because this row of connectors here is unused. So yeah, you could say this amplifier was built a bit as a one-size-fits-all by Sony. A very stout, a very classic, very stout transformer. I like that. And it's also very well shielded. What else could I, or should I say? Oh yeah, one more little detail. If you take a close look at the heatsink for the power chip, you'll notice that the screws that tie it down to the chassis, okay, are insulated by little nylon washers. Let me see if I can give you a close-up. There. You see the nylon washer below the screw? And also, you see that plastic strip that runs between the chassis and the heatsink. So the heatsink is electrically isolated from the chassis, okay, and that would suggest that the body of the chip, at least at the back, is conducting electricity. Yeah. So in order to avoid any shorts, the heatsink had to be insulated from the chassis itself. All right. So yes, well, it's a good little amplifier. It's 2 times 20 watts. The specs are not spectacular, but are what one would expect of a mid-range amplifier. And like I said, the design looks really clean and typical for the 80s. Alright, the amplifier will be set to low volume, the loudness on, bass in a medium low position, treble in a medium high, and a balance in the middle. Also, I've hooked up my little smartphone tuner to the tuner input of the amplifier. I'm not going to dwell very long on any particular channel, but I just want to give you an idea of the sound that's produced through this amplifier. So here we go.
C'est vrai qu'on peut se poser la question du pourquoi. Pourquoi ils ratent leur entame? Est-ce qu'ils se mettent déjà une pression par rapport en termes de points sur l'écart qu'ils ont avec le Bruges? Est-ce qu'ils ont besoin de se faire bousculer, comme c'est le cas depuis 3 rencontres, pour se remettre dedans et revoir l'union que l'on connaît? Le plus flagrant, c'était surtout à OHL, où ils sont menés. Et je me disais, ça fait déjà 2 fois. Et bon, ils reviennent au score, et puis après, ils déroulent. Et puis ils déroulent.
Co-commissaire de l'exposition Le secret des espadons. L'exposition Le secret des espadons se tient donc jusqu'au 16 avril 2022 au Centre belge de la bande dessinée à Bruxelles. Toutes les informations sur les conditions de visite sont à consulter sur le site cbdd.be. cbdd.be.
There you go. The Sony Stereo Amplifier TA-242, or like they used to say in the 80s, an integrated stereo amplifier. I hope you liked watching this episode, and well, I'll welcome you back to my channel for a next video soon. Thanks for watching.